So today we're adding and subtracting polynomials. Everything about adding and subtracting is almost exactly the same as combining like terms, which is what we did back in 6.1. Right now, if your nose is out, put your nose away. I see 1, 2, 3, 4. Brandon, put your nose away. Okay, so go ahead and throw your name on here. These will get glued in. Put your name on just for good measure. And then we've got some steps here. So steps to adding polynomials. First thing that we're going to do is drop the parentheses. So just ignore the parentheses. And then we're going to combine like terms. Steps to subtracting polynomials. This is the important one. We have to distribute the negative to the polynomial that we are subtracting. So if we're subtracting everything in an entire set of parentheses, we've got to distribute that negative. Then we can ignore the parentheses and combine like terms. Like terms, we did those in 6.1. Like terms have the same variable and exponent. We need to remember that when we combine like terms, we add the coefficients. We do not change the exponents when we are combining like terms. So some of you guys, when you are combining like terms at the end of multiplying, you are making the mistake of changing your exponents. Don't change the exponents when you're adding and subtracting. Currently got a phone out. Put that away, please. Okay, and then the last thing here is we are still always, for this entire unit, going to write our answers in standard form, which is our highest to lowest exponent. Any questions right now? All right, I'm going to try to use some shapes and color code to help us as we go through these. So first one here is an addition problem. So that's the first thing that you need to pay attention to, is whether it's addition or subtraction. Because if it's addition, you really just combine like terms. So this one's addition. So we are literally just adding all of this with all of this. We are going to go from highest to lowest exponent. First thing I've got is this 8x squared. And that can get combined with this 2x squared. So 8x squared plus 2x squared is 10x squared. Okay. Next one I've got is just my x's, my x to the first power. I've got 3x, and I've got negative 5x. This is where you have to be careful. You can think about it as 3 plus negative 5 or 3 minus 5. Either way, it ends up being negative 2x. Okay, and then our last one, we have our constants, which are the numbers by themselves. So we've got negative 7 and positive 3. Negative 7 plus 3 is negative 4. So for this one, it's really just a combining like terms problem. Brandon, Manuel, Nathan. Put your noses away. Okay. Any questions on that problem? Okay. We'll move on to our next one then. So the next one is a subtraction problem. And how you know is you literally just look, there's a subtraction sign. So we're doing this minus all of that. If I am subtracting everything in here, this is like taking an entire basket full of stuff. The parentheses are like a basket, and we're taking everything inside of it. So we've got to take this minus sign. I'm going to put an imaginary 1 right here, and I'm going to distribute that negative 1 to everything in the parentheses here. Come grab a note sheet. I think Miss Burgess didn't realize you were here because there's notebooks everywhere. Okay. So we're going to do negative 1 times 3, which will be minus 3x cubed. Negative 1 times negative 5x squared, which will be plus 5x squared. And then negative 1 times 2x is going to be minus 2x. So basically, you take everything that was positive and it becomes negative, everything that was negative and it becomes positive. So when you are subtracting, that should always be your first step, is to distribute that negative. People who don't distribute the negative always forget to subtract by the end of it. They don't always forget, but it's really easy to forget to subtract if you don't explicitly distribute the negative. Any questions right now? Yes.
You have to do the other side the same way?
No. And the reason why we don't is we're doing this minus this. So like this minus that. We're only subtracting this one.
Okay.
Yep. Good question. So you only distribute the negative to the one after it. The negative has to be before it. Okay, now we're going to subtract, or combine like terms, I guess, because now we just ignore the parentheses and combine like terms. So we've got 2x cubed and negative 3x cubed. 2 plus negative 3 is negative 1. So I've got negative 1x cubed. I could also write negative x cubed if I wanted. I don't necessarily need to have that 1 there. Next up, I've got 6x squared and 5x squared, both positive. So 6 plus 5 is 11. X squareds. And then my last one, I've got 8x and negative 2x. 8 minus 2 is 6. So I've got plus 6x. And again, when we're combining like terms, we don't change the exponents. Nathan, Brandon. Knows. That's what it's going to be every time. Okay, any other questions? All right, go ahead and flip this over. Then we've got 2 more examples on the back, because these ones were both really nice, where like they were in order and everything combined, all nice. We've got 2 examples on the back, because sometimes we don't have everything to combine nicely. Sometimes we like only have 1x cubed, or only have 1x, or only have 1 constant. So the next one we've got here is an addition problem. And my highest exponent here is 6x cubed. But if you guys look, there are no other 6x cubes. So since it's addition, we're ready to just combine like terms. 6x cubed is going to go first. And it just stays by itself because there's no other x cubes. Then we've got 5x squared. And there's no other x squareds, so it just stays by itself as well. So plus 5x squared. Okay, we've got minus 3x and minus 8x. Those can combine together because they're both x's, or x to the first. So negative 3 plus negative 8 is negative 11. And then to finish this out, we've got 7 and 1. Those can get combined together. So 7 plus 1 is 8. All right. Any questions on that example? So that one, the thing that was different about it is not everybody had someone to add with. So that x cubed there was only 1 x cubed, there was only 1 x squared, it all stayed separate. Okay. Last problem on here is another subtraction problem. What is the first thing that we need to do in a subtraction problem? Multiply what by what? Yep, so multiply everything you're subtracting by negative 1. Or a fancy word for that is to distribute. So we're going to distribute a negative 1 here. So negative 1 times 7x cubed is going to be minus 7x cubed. Negative 1 times 8x squared is going to be minus 8x squared. And then negative 1 times negative 3x is going to be plus 3x. Let's go ahead and distribute that. Once you distribute, you then ignore, you can ignore that top one. You do these three with these three. It's also not always 3 and 3. It's just the way it is on your notes. Okay, so then we're going to combine like terms now that we've distributed. So our highest exponent is x cubed. And again, on this one, I only have one x cubed. It's just this negative 7x cubed. So that's going to go very first. Negative 7x cubed. Hold on. Let people see it. Okay, then the next thing we're going to do is the 8x squared and the negative 8x squared. So we're going to combine by terms here. We've got 8x squared and negative 8x squared. Now you can say it, JP.
We just get rid of it?
Yep, so they just cancel each other out. So 8 minus 8 is 0. They just cancel each other out. And it does not appear in your answer anywhere because we do not mention the fact that we have 0 of them. We don't advertise that. Then the next one we've got is 3x and 3x. Those don't cancel each other out because it's 3 plus 3, not 3 minus 3. So 3 plus 3 is 6, so we've got 6x. And then to finish each other out, we've got just that negative 5. If you guys notice, I'm just using random circles and squares and triangles and underlines to kind of show where things are the same as each other. Okay, any questions on these examples? Okay, I'm going to go ahead and stop the recording then, and then let's go ahead and glue these in, and then we'll get started on our assignment.